students. Our today's topic is integration. It's from algebra for the students of A levels, year 13 or grade 12, and FPISC grade 12 and CBSE grade 12. Integration is an inverse process of differentiation. Differentiation is the process of determining the rate of change in function on the basis of its variables. For integration, instead of differentiating a function, we are given the derivatives of a function and asked to find its primitive, means the original function. Like function, when you differentiate it, you get its derivative, and when you get the antiderivative of this derivative, you get the function again. So this is the process. To solve the questions for the antiderivatives or the integration, or to find the integrals, we must remember some of the formulas, and some of those formulas we have written here. You can see that they are the formulas of derivatives as well as antiderivatives. Antiderivatives we call integrals. The derivative of x is equal to 1 here, and find the integral of 1. This means the answer is the function whose derivative we have found, like this is x, and we write the constant of integration with every answer. So we must memorize these formulas. If you have integral of x power n dx, this means we shall be writing x power n plus 1 whole over n plus 1 plus c, whereas n is not equal to negative 1. So you know that the derivative of sine x is equal to cos x. So we can say for the integral of cos x will be sine x plus c, as you can see here. Similarly, the derivative of negative cos x equal to sine x, and integral of sine x, we may write this function instead, and this is the answer for minus cos x plus c. d by dx of secant x will be equal to secant x and tan x. Whereas we go the opposite way, we take the integral of the answer for the derivative, and we get the function whose derivative we have taken as an answer of integral of this answer, okay, of the function. So this is the way how we integrate. Let us do the practice with the help of some questions. Question number 1. Sine of 2x dx. As per the formula we have learned earlier, like integral of sine x dx equals negative cos x plus c. But here it's not the x only, we have 2 as well. So we must be writing here equals negative cos 2x, but down here we need to write here 2 as well plus c. So we discussed the reason why we are writing here 2 at the bottom or in the denominator. Since you have a function of x, right? This is a function, but the derivative dx must be having the complete derivative of sine of 2x. So if we take the derivative of sine of 2x, what we get? Sine 2x, the derivative of sine of 2x will be sine 2x times 2. So it becomes 2 sine 2x. You remember this one? We have done this in the solution of differentiation. Now, what we need? We have only sine 2x here, but we do not have 2. So that we may show that this derivative of sine 2x equals sine 2x times 2 dx. So to make this 2 over here, we write here sine 2x dx. Here we divide and multiply by 2 so that we may get it 1 upon 2 sine 2x times 2 dx. Now we can write and apply this formula here. So it becomes 1 upon 2 negative cos 2x plus c. So we can rewrite it as negative cos 2x upon 2 plus c. This is the answer for question number 1. And we can do the same when we choose question number 2, that is cos of 3x. Same way, we write here integral cos 3x dx. To make it dx as the derivative of cos of 3x, we rewrite it 3 by 3 cos 3x dx, or 1 by 3 integral cos 3x times 3 dx. So now the function is cos 3x and its derivative is 3 dx. So now we can write it as 1 by 3 sine of 3x plus c, or sine 3x upon 3 plus c. Understood? I think this is easy one now. Question number 3. So now the question 3 states we find the integral of e power 2x dx. Same way, we must have the function plus its derivative. But when we find the derivative of e power 2x, it becomes e power 2x into 2. To make it d power 2x equals e power 2x times 2 dx. We make this 2 and we divide and multiply as we did in with question number 2. 1 upon 2 integral e power 2x dx means inside 2 dx. Now we have the function and we have its derivative. Becomes 1 by 2 e power 2x plus c. Because we also know that the integral of e power x is equal to dx is equal to e power x itself plus c. So we have the power 2x, it means we shall write 2 in the bottom. Okay, this is the answer. Now we do question 4. We apply the same formula here. The derivative of inside this function must be a only, because if you take d by dx of ax plus b, a and b are constants, so it becomes a only, because the derivative of this constant will be 0 and the derivative of this x is a only, so we write a into dx here, and we can say that 1 upon a integral ax plus b whole square times a dx. Okay. Now we apply this formula. The formula is x power n dx equals x power n plus 1 upon n plus 1 plus c. Now, you know this x is ax plus b and the dx is a dx. Okay, so now we can apply the same, and the n is equal to 2 here, right? This is n, and this one is x. 1 by a into ax plus b whole power 2 plus 1 over 2 plus 1 plus c, because this is the derivative and this is the function itself. Okay, now we write ax plus b whole power 3 upon 3a plus c is the answer for this question. The integral of sine 2x minus 4 e power 3x. Sine 2x minus 4 e power 3x. Okay, we write it with dx. If you are given this kind of bracket, so we open the bracket with dx. We separate these two functions because we do not have any power here. We can do it like that. So we rewrite it sine 2x dx minus 4 integral e power 3x dx. To make it more simpler, we don't write 1 by 2 here and then write 2 here. Simply we make our own method. Whenever you have sine of 2x, you may write here negative cos 2x upon 2. So whatever the number, it's the multiple of this variable, you write that in the bottom or in the denominator of n. Now minus 4 will become as it is and e power 3x over 3, as this 3 is the multiple of x, plus c. This is answer. Of 4e3 power 3x plus 1, we apply the same method as we were done already. This is integral of 4e power 3x plus into dx, means we have opened the bracket, plus integral of 1 dx. As we have already done this in the formula, that by integral of 1 dx will be x only. So we can write 4 e power 3x upon 3 plus x plus c. That's it. Question next. This is x square times 1 minus 1 upon x square bracket close dx. So if you get this kind of questions, x square, open the bracket, x square minus x square upon x square bracket close dx, and we get here very simple answer, x square minus these two x squares will cancel each other and we are written only y, only 1, so it becomes dx. So here opening the bracket, x square dx minus 1 dx, or write only dx. This is x power 3 upon 3 minus x plus 1, no, plus c. This is the answer. Next question, ax square plus bx plus c dx. Here a, b, c are the constants, or a, b are the coefficients of x and c is the constant. Again opening the bracket, but this time we shall write this constant outside the integral sign. So it will be a x square dx plus b x dx plus c integral dx. Now it is a times x power 2 plus 1 means 3, x power 3 upon 2 plus 1, this is 3, plus b x square upon 2 plus cx plus d, because here c already here, so as an additional constant we can write any other variable, any other the letter from alphabets. So this is the answer. Now for this question we try again, 2x square plus e power x dx. So separate it now, 2x square dx plus e power x dx, and you have 2x power 3 upon 3 plus e power x plus c. That's the answer. How quickly we are doing it, I hope you understand it well. The next question, a little complex questions are coming up now. We can open the bracket always whenever we do not have any power on this function. We write here 2x squared dx minus 3 sine x dx plus 5 square root x. We can write that x power 1 by 2 dx. Okay. Now we can differentiate these all terms separately. 2 times x power 2, here we make it 3 divided by 3. Okay. Minus 3. So the integral of sine x is negative cos x plus 5 x power 1 by 2 plus 1 over 1 by 2 plus 1. And this is plus c. This is constant of integration. Now we rewrite it. 2 by 3 x power 3 minus times minus will be plus 3 cos x plus 5 times x power 3 by 2 over 3 by 2 plus c. Or if we can rearrange it again, so we can write as well 2 by 3 x power 3 plus 3 cos x plus 2 will go up, it becomes 10 upon 3 x power 3 by 2 plus c. This is your answer. The next question is all about trigonometric functions. When we open the bracket, what we get? Secant times secant will be secant square x. Now we multiply the secant, we multiply, now this will to the tan x. So secant x tan x. Okay. This will be full dx. Now we rewrite it opening the bracket. Secant square x dx plus secant x tan x dx. From the formulas, we know that the secant square x dx is equal to tan x, because the derivative of tan x is secant square x. Similarly, the integral of secant square x is tan x plus secant x in tan x. Secant x times tan x will be secant x only. And then this is plus c. Isn't it easy? The thing you must do it is to remember some of the formulas. If you memorize those formulas first, and every question of integration you can do with a great ease. Secant x is equal to 1 upon cos x, and whereas cosecant x is equal to 1 upon sin x. If we can rewrite that, and we can write 1 upon cos x instead of secant x, and 1 by sin x instead of cosecant x. What the function will be? Here it will 1 upon cos x square upon 1 upon sin x square dx. So it will be, this sin x, it will be 1 upon cos square x over 1 upon sin square x dx. Now this sin square x will go upside, and as per the rules of dividing the fractions, second fraction will be inverted. So it will be 1 upon cos square x times sin square x whole times dx. Integral of sin square 1 sin square x upon cos square x dx, or it becomes tan square x dx as well. But we do not have any formula for the integral of tan square x. Trigonometric identities like tan square x is equal to secant square x minus 1. Okay. Secant square x dx minus dx, because 1 we don't write. So it becomes secant square x dx. We have the formula which is tan x Now minus x plus c. Isn't it easy one? 2 upon cos square x minus 3 sine x upon cos square x. This one becomes 2 secant square x minus 3 sine x upon cos x into 1 upon cos. We separate them. 2 secant square x dx minus 3 sin x upon cos x is tan x and 1 upon cos x is secant x. You remember the formula for tan x secant x integral? That will be secant x. And the formula for and the answer for integral of secant square x will be tan x. And these two remain with it. Plus C. This is your answer for this question. The question seems always complicated, but it becomes so easy when there are trigonometric identities are involved. Hope you understand today's lesson. Just do write if you have any question or any doubt in the comment box. And if you like the video, kindly subscribe it, press the bell icon and share it with your friends so that they also get the benefit of it. Thank you very much for watching. See you till the next video. Bye bye.